Let us begin. If you have no problem, no doubts, then today we are going to start our new section, that is, although it comes in electrostatics, but it is a new chapter, of our competition exam, that is NEET exam, and it is capacitor. We are going to start that chapter, and I will complete this chapter within 2 class. Okay. Now, capacitor. Let us begin with the topic capacitor. Let us assume. Suppose I'm assuming that I have one conductor. Suppose I'm assuming that I have one conductor and I have given some charge to it, Q. If I'm giving some charge to it, it will gain some potential, because we know V is equal to depends upon K charge only. That we know. You have studied in electrostatics also. Suppose we are giving the charge to a conductor and it is gaining potential. So we can say that Q is directly proportional to V. That is, we are giving the charges and it is gaining the potential. Okay. So if charge is directly proportional to V, to remove this proportional sign, we can put one constant, that is C and V, and this constant is called as C is called as capacitance of, this is called as capacitance of conductor. This is capacitance of conductor. So it is written here also that if a charge Q is given, potential increases and proportionally like this. So Q is equal to CV, and C is capacitance of a material. It depends upon the material. Now we can say that C is equal to Q by V here. Now, what can we understand from here? We can see that if C is equal to Q by V, to increase the capacitance, if we want to increase the capacitance, what we have to do? We have to decrease the potential, because we need that capacitance of the conductor should be increased. So increase the capacity, we have to decrease the potential. Okay. Now, in our next slide, we will study how to decrease the potential of a conductor, so that if potential is decreases, then its capacitance will be more. So let us discuss how we can increase the capacitance of a material. Let me assume one conductor here like this. It is having some charge, positive charge. Let us assume it has charge Q and some potential V. Now, if I want to check how much charge is present, how will I verify it? I have one instrument that is called as GLE. Okay, I will touch here and it will show the deflection, and with that deflection I can measure the charge and potential. Remember, to increase the capacitance, I have to decrease the potential. That I know. That is my aim. Okay, that is my aim. So I read that I came to know that this much deflection, so that this much charge is present. So I want to decrease the deflection, because I know if deflection will decrease, charge will decrease, and if charge is decreasing, then V will decrease. Now accordingly, let us assume in second case, what I did here, near this plate, positive plate, which I have charged with Q, I put another plate of similar dimension here, like this. What will it do? It will charge it through induction, like here, like this. It will charge here, attract negative charge here and positive here, like this. Okay, minus Q here, plus Q here. So if we will verify, we will check the charge present here, we will find that the deflection is slightly less than this, because it will be slightly less than this because of the charge which is present here, negative charge, bound charge. So some deflection will be less as compared to this first case. In second case, what we assumed we did that this negative charge, since it is bounded with this positive charge, deflection will decrease very slightly. But It is not decreasing sufficiently because of this charge is present here on the other side of this plate. In third arrangement, what we did that the positive plate that was originally present here is present here only, but the other plate which we have put here, negative, is present here. What we did, if we suppose, we know that if this charge is removed, then only negative will remain here, and if only negative will remain here, this will have maximum, the deflection will decrease, it will have maximum capacitance. So if we have earthed the other side of this plate, what will happen? Only the negative side charge will remain here, and we will see that the deflection of this gold deflectoscope is minimized. So what we came to know that when arrangement of conductor is done in such a way that one is having positive Q charge and another is having minus Q charge, then this arrangement of conductor will have minimum potential. This will have minimum potential V, and if it is have a minimum potential, that means capacitance will increase, and this is called capacitor. What is capacitor? We came to know here. Capacitor is a arrangement of conductor. Capacitor is arrangement of conductor having minimum potential or maximum capacitance. Now look at the proper definition here. What is capacitance? Capacitance is the arrangement of conductors having higher capacitance or minimum potential. Okay, any problem in definition, understanding the definition of capacitor? Any problem? Okay, now let us see. If we have came to know what is capacitance, and we know C is equal to Q by V. So if we want to write the SI unit of capacitance, SI unit of C, what we will write? Charge, we know it is coulomb, and for V it is volt. We can write like this: capacitance SI unit is coulomb per volt, or we called it as farad. Okay, we call it as farad, and we usually measure in micro, milli, like that, and you know all those conversion, so I'm not going there. Secondly, if we want to know, and in short we call it as F, and if we want to write the dimension of C, what will it? For charge it is IT, we have studied, and for potential we know V is equal to U by Q. So dimension of potential will be what? It will be energy, we know ml2 t minus 2, and charge is IT. We will put here all those and solve it. We will get the dimension of capacitance. Any problem? Should I solve all this? You will try all this. Okay, please interact. Okay, yes, you have to do, you should do it, because these are section important, but you have to try. What you will do, you will just put the values here. These values you have to put here like this: ml2t minus 2 and it. Here it will go up. What we will get? We will get I square t square m minus 1 l minus 2 and t as plus 2. We will solve this and get the answer. Okay, this is the dimension of capacitance, and this is the unit of capacitance. Okay, now one more thing, you know milli suffix means 10 to the power minus 3, micro, milliamp, micro like this, 10 to the power minus 6, and nano. This will be frequently used here. Okay, now let us move further. Now Let us see. We are going to study what is dielectric. Okay, actually, believe me, dielectric is just a type of insulator. It is a type of insulator only. It is not a conductor, but it is a type of insulator. Not conductor, not semiconductor, but an insulator. Okay. Dielectric is usually of two types. One is called as non-polar dielectric. Non-polar dielectric, and one is called as polar dielectric. Non-polar means like this. It is having structure like this, electron cloud like this, all revolving here. Okay. Okay. They have non-polar means the center of the electron cloud, and the center of a nucleus coincide together. So they are called as non-polar. They get polarized in the presence of electric field, but after removal of electric field, they come to their original state like this. Okay. But for a polar dielectric, what is present here? There are charges are separated by small distance. That is the center of the nucleus and the center of electron cloud never coincide here. In which case? In case of polar dielectric, they are separated by some distance like this, and we call it as dipole. And we say that dipole is formed in polar dielectric, permanent dipoles. Here it is not a permanent dipole. In polar dielectric, there is a permanent dipole. Polar dielectric example, HCl, which is a polar dielectric. H2O, polar dielectric. Non-polar, Cl2, H2O, non-polar molecules like that. Sorry, H2O not, Cl2, and like we can say ammonia. Ammonia is although some about polar only. H2, we can say that H2 also non-polar. Okay. Now these are two types of dielectric, polar and non-polar. What we have to study here, we are not bothering about what is polar, what is non-polar. Only we are considering here like that. We are considering that if suppose in a polar dielectric material, this is a polar dielectric material, if suppose there is an electric field, if it is suppose when electric field is not applied, E is 0, what will happen? We are studying, remember, we are considering only polar dielectric. We are not going to talk about non-polar dielectric. We are only talking about polar dielectric. For a polar dielectric, when electric field is not present, there is a random dipole present like this. They are permanent dipoles like this, present randomly like this. They are present everywhere like this. Okay. When electric field is 0. But as soon as we apply the electric field, suppose we have applied the electric field in this direction like this, what will happen? What will happen if we have applied the electric field? We know force is equal to QE. Now we will see that the positive side of this dipole will goes to this side like this. They will get arranged like this. And negative side will get arranged like this. How it will happen? Let us see how will it happen. We have applied external force. This is external electric field. Let us say external electric field in this direction. What will happen? Along the direction of electric field, positive charge will move this side, and electron will be on the other side. But the electron will try to move this side. But since it is attached in a molecule, it can't go outside the molecule up to certain limit of the electric field. Now, since in the opposite direction, what will happen? Negative will go here, negative will go here, and positive will try to go to right side like this. Okay, they will get arranged like this. What will happen? We will see that all positive charge get present here like this. That we will get positive charge density here and negative charge density on this side. And since there is a positive charge here and negative charge density here, we will get another electric field inside the dielectric, and this will be E internal. Okay, so this internal electric field is due to this polarized charges, charge density sigma plus and sigma minus. What we will say that E net electric field inside dielectric, what will be? It will be E external minus E internal. If E external is E, we say it E, and E internal we say it as E dash. We say it as E dash. Then E minus E dash, it will be equal to, it comes to be equal to, when we calculate it, it comes equal to be E by some constant K. Remember, this is net electric field formula. We see that net electric field will be external minus internal, and it is equal to E by some constant K, and this constant K is called as dielectric constant. Okay, we have studied about this dielectric constant. It is also called a relative permittivity, also called a specific inductive capacity. We have learned all this. We have also came to know that for dielectric constant K is equal to 80 for water. Water has K is equal to 80, and K is equal to 1 for vacuum, and for air also we take approximately 1, and it is infinity for conductor. Okay, these three value you should remember. These are standard value. Okay, any problem to anyone till now? Any problem? Please tell any problem to anyone. Okay, please make interactive session. All of you should comment. Okay, now let us see what we have seen. We have seen that external electric field, this has applied forces and the charge distributed like this. If suppose I increase this electric field up to a large amount, increasing, what will happen? The charges, this positive charge, although it's attached in the molecule, but it tries to go to other side, and this negative charge, although attached in the molecule, but it tries to go on the other side. But if this electric field is increased by a large amount, by a high amount, what will happen? This negative charge will get detached from the molecule, and this positive charge will get detached from the molecule, and they will go, the positive will go right side and negative charge will go left side. And this situation is called as breakdown condition, and dielectric will behave as a conductor. Okay, let us see what will happen. We have discussed now here also that if electric field is increased very much, up to, remember, like this 10 to the power 6 voltmeter of this order, what will happen? What happens that the positive charge all goes there, all comes here, all positive charge comes here, all negative charge comes here, like this, and dielectric has number of charges, free charges present in it, and dielectric behave as a conductor, and the dielectric behaves like a conductor. What was originally? It was dielectric, but after breakdown it becomes conductor. Okay, and this situation is called as dielectric breakdown. And the value of electric field, the minimum value of electric field, after which this phenomena occurs, this is called as electric field strength of a dielectric breakdown, or we say as dielectric strength. Okay, when we say dielectric strength, It means the value of electric field, minimum value of electric field, after which dielectric breakdown occurs. We can see here, I have coined some point here. If electric field increased, electrons get detached from the atom and dielectric becomes conductor, and this phenomena is called as dielectric breakdown. And we tell as this dielectric breakdown occurs. And also the minimum value of electric field, we can see here the minimum value of electric field after which breakdown occurs. That value of electric field is called as dielectric strength of the medium. Okay, any problem to anyone? Any problem to anyone? Okay, okay, okay. We will come to know some more terms about dielectric, that will be polarizability, what is polarizability, susceptibility, and also we will come to know about dipole moment per unit volume in further topics. Okay, in capacitor we are considering this only. Okay, now let us come to the point. First type of capacitor, what we are considering here, it is parallel plate capacitor. It is very important, we should study it. Now what happens, let us suppose two plates, we have studied till now. If two plates, they are attached with some potential V. One plate is having charge plus Q, another plate is having a charge of minus Q. They are separated by distance D here, and inside it is only air filled, nothing filled. Okay, to find the capacitance, remember some steps. We know to find the capacitance, only first step you should know, you have to write the value of V, potential difference. If you know the value of potential difference, second step, you have to write only C is equal to Q and the value of V obtained from here. You will get the value of capacitance here, the value of V obtained from first step 1. This is only the step. I will show you in brief shortcut method how to write the capacitance. Okay, now let us see. We know that we have studied earlier also in our Gauss law topic that for an infinite plate, we know that electric field outside will be 0. You have studied earlier also, outside will be 0. For inside, electric field through positive plate sigma by 2 epsilon naught, and for negative plate sigma by 2 epsilon naught. Okay, we will say that inside electric field will be sigma by epsilon naught. Now we can say that potential difference V, what we know? We know that dV is equal to minus E dot dr. Taking only the magnitude, we can say that potential difference V is equal to electric field into distance between 2 points. Okay, so using this we can write as V is equal to electric field. What is the value of electric field? Sigma by epsilon naught into distance between the 2 points. 1 point here, a charge has to field is moving from here to here. So we will say that field is between this to this and distance between them is D. Okay, we will write electric field into D. What it will be? And we know sigma is charge by area, epsilon naught D. We got the value of V. Next step, what we will do? C is equal to charge by, divide this by V. And we can see here step 2, C is equal to Q by, divide it by here, D by epsilon naught A. We will get the value of capacitance as C is equal to epsilon naught A by D. Okay, this is the value of capacitance of a parallel plate capacitor. Okay, it is only applicable when there is air filled between them. Okay, any problem? Any problem? Okay, 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 okay. Very good. Okay. Now this is, let us take first case. It is telling that let us suppose, remember these are very important for your exam. Okay. Now, their state, okay. Though I have done some curved is occurred, but they are straight lines. Okay. Now it is telling that if in between these two parallel plate capacitor, let us assume what I have did, I have filled one material here like this, totally filled. And suppose we have filled one material here, which is a dielectric, and let us suppose dielectric has dielectric constant of K. It is having plus Q charge, here minus Q charge. What will be the result? So it was given by Faraday, and we call it as Faraday's observation. Is called as Faraday's observation. What Faraday told that if capacitor is filled with dielectric, then what we will do? We do that epsilon naught, we replace epsilon naught by K epsilon naught. You remember that Coulomb's law? We write the same thing there also. What we did, and we called it as epsilon. You remember there, K epsilon like this. We have written in our class also. Okay, this was the Faraday observation. That means C will become nu. C dash will become, what was the formula? Epsilon naught. It will be replaced by K epsilon naught A by D. Okay, so we can also write it like this: K into original capacitance. Okay, any problem? This is applicable only if remember one word here, which is written completely filled, not partially. It is completely filled, then only we can apply this formula. Okay. Okay, remember all this formula. We will be using this formula during question solving. Okay, now let us move further. Suppose in a parallel plate capacitor, I take one good example, good case. Let us suppose I have filled it with a material having a dielectric constant K. Let us assume the thickness of the distance between the plate like this is D, and the thickness of dielectric is T. Here we know that if it is having plus Q charge, it is having minus Q charge, since we have applied one biased here like this. Okay, now what we have to do? We have to find the capacitance. How we will find? First step, we know step was find V, and V is E into D. Now we know here it will be electric field E. Inside electric field will change. Here again electric field will be E. And we also know that we have learned in our previous topic, inside the electric field becomes how much? E by K. We have learned now before 2 slide, I think. Dielectric, I have shown you like this formula. Inside electric field, inside dielectric, electric field becomes E by K. So we can write V is equal to, what we will write? We will see that electric field E is present here and here. We will write E is present where? Present total distance D, here thickness T. So electric field is present where? Totally D minus T. We can write like this, plus inside this dielectric material, electric field is E by K and thickness is T. Any problem till here? Any problem? Okay. one more thing you should remember here. One more thing you should remember here. What I did. One more thing you should remember what I did. You should remember that I have replaced. I can replace if we know if dielectric strength is K, we know that it was I have written E by K and thickness is T like this. It is having dielectric strength as K. We can write like this also. E, see, we can write like this. E by K into T. We can write like this now. E into T by K. What does it mean? It means that if we replace this dielectric material by air column, if it is having air column, air column or vacuum with thickness of T by K, then also potential will be same. Here electric field will be E, and for this what will be the potential? V is equal to E into T by K, and for this also potential will be E by K into length T, both same. So we can replace the equivalent of the dielectric field, dielectric material, with air column. We can replace it like this. Okay, we can write it like this: air equivalent of dielectric, air or vacuum equivalent. Okay, any problem to anyone till here? Any problem? Please ask any problem to anyone. You can ask any problem. Okay. Now we can see that it is replaced like this. So if we have replaced like this, okay, now we know that V is this much. Similarly, we will write here V is equal to, we will put all those value of E here. What we will get? We get C is equal to epsilon naught A by D minus T plus T by K. This is the formula when we have partially filled dielectric, and this is equivalent air column of dielectric. This is equivalent air column of dielectric, and this was the real air column, the real air width which was present, and this was the equivalent air width of dielectric material. Okay, and you should remember this formula. It is very much important. Okay, any problem to anyone? Any problem to anyone? Okay, now let us move further. Okay, now we will using that formula in our question solving also. Now this is also important case. If what is here, if we have number of dielectric material, let us suppose like this, we have number of dielectric material, all are linear here present. Thickness is T1, thickness is T2, thickness is T3, thickness is T4, and so on. Dielectric constant K1, K2, K3, K4, and so on. And last one is Kn, and thickness is Tn, like this. For this plate having multiple dielectric in between the plates, how to write the dielectric capacitance of this parallel plate capacitor? How we will write? We will write C is equal to epsilon naught A by, we will write the equivalent air column. What will be the equivalent air column? T1 by K1, T2 by K2, like this. We will write T1 by K1 plus T2 by K2, okay, plus T3 by K3, and so on. Okay, this is the formula of capacitance when we have multiple dielectric. Okay, got it? Or any confusion in this diagram which I have drawn? Any confusion? Okay, okay, right, right. Any confusion? Any confusion to anyone? Okay, okay, okay. Now we can have some questions also, because we have done lots of theory part. Now we will move further and we will look into the question. Okay. Now, first question. First question. First question is that if suppose I have dielectric material like this, and it is given that we are having here, we are having a metal, okay, metal, and originally, okay, it is telling that originally capacitance was C. Capacitance was C is equal to epsilon naught A by D. Originally, D was the thickness between the plate. Here, what we did, we placed one metal having thickness T. What will be the new capacitance here? This was original. We have put here modified form, modified capacitor. What will be the C modified? Please comment. I give you 10-second time. Answer will be in terms of dt like that. Infinity, infinity. Let me see how infinity came. C is equal to, we know, epsilon naught A by what it will be? D minus T plus T by K. Like this. Epsilon naught A by D minus T and T by K. T by K means K is infinity. It will be 0. Answer will be epsilon naught A D by T. How infinity came? This will be the answer now. Okay, any problem? This will be the answer. Okay. Okay. Let us move further. Okay. Now, let us move further. Let us see next question. One more question. Now, if suppose originally I was having capacitance C, what I did, I filled it like this. D by 2 with K is equal to 20, and here D by 4 with K is equal to 10, and with here D by 4 as K is equal to 30. What will be the new capacitance? See this. Can you try? Can you try? Please try once. Please try once. Please try. What will be the answer? Please try. Try. Please try. Okay, no worry. No worry. Not getting answer, no worry. Let us see. What will be the answer? Let us see. We know C is equal to epsilon naught A by D. Okay. If you are confused with the measurement part, always take C is equal to epsilon naught A by D. Okay. Now, what we will write? You will write like this. What we write? T1 is equal to T1, and T1 is equal to D by 2 T1 by K1. K1 is 20 plus T2 D by 4, and K2 is 10 plus T2 plus by T3 by K3 is 30. So solve all these values and put epsilon naught A by D like C. What you will do? C dash will be epsilon naught A, take D common, D will be common, you will get here like this, some value. What it will be? It will be here like this, you will get like this, 1 by, it will be 1 by 40 plus 1 by 40 plus 1 by 120 like this. Okay, this is the value of capacitance C originally given here. You will put C dash is equal to C into this factor. Solve this factor and put the value here. You will get the answer. Any problem? Should I solve it? Come to answer, get the answer. Any confusion here? Any confusion? Clear? Okay. This is the part, question part. We will do lots of question also. First, we are focusing on completing the question part. After that, we will be discussing more questions here. Now, let us see one more concept, which is combination of capacitors. Combination of capacitors. You have studied all these things in your class 10th also. First combination is, we will study here, it will be parallel combination, because parallel combination is easier here. That's why we are studying parallel combination here. Now, let us see parallel combination. We assume one capacitance is like this, one capacitance is like this. Okay, one capacitance is like this here, all are joined together like this with a battery V here like this. It is C1, C2, C3. We know here it will be V. If suppose it is providing charge Q here, it will go Q1 this side, Q2 this side, and Q3 this side. Sorry. Now we know at this point we know that Q will be Q1 plus Q2 plus Q3 like this, and also we know that Q is equal to CV. We will say Q, replace this Q by C equivalent into V is equal to Q1. Capacitance is C1 and potential is V1. V. Capacitance C2, potential V. Capacitance C3, potential V. We will get cut on the both sides. We will get C equivalent is equal to C1 plus C2 plus C3 like this. Okay. This is the formula of grouping for a parallel capacitor. Okay. What now? Only just remember the formula and some derivation part, because it will be very much important also. Now, we have learned how to group capacitor in a parallel combination. Let us see series combination, then we will be able to solve a good questions also. Now, second is series combination. Let us see series combination. What will happen? Let us assume this is a capacitor. Okay, this is C1, this is C2, this is C3, and they are connected through a battery having potential V. We know charge Q, potential V, charge Q is supplied from here. What will happen? Charge Q will appear here, plus Q, minus Q here, then plus Q, minus Q, plus Q, minus Q. Series combination charge is same. Now, we will say that, look here, this potential, and this potential. Let us say this potential is V1, this is V2, this is V3. Here, its potential was V1 from V1 dropped, we got V2 like this. Let me draw one diagram. This diagram is very important. Okay, it has come in an exam also. Okay, now you see what will be the formula. We are drawing here potential graph. Originally, it is V. After passing through C1, V becomes V1. What will happen? This will become V1. When? After passing through Q1, after passing through first capacitor C1, what will happen? We will see V1 drop. Okay. After that, V1 will move further and V1 will drop to V2. V1 will drop to V2. Like this, V1 will drop to V2. Here V2. Further, what will happen? V2 will drop to zero potential. What will happen? It will drop to zero potential. Okay, and this drop is what is the drop here? It is V1 is equal to, we know Q is equal to CV, V is equal to Q by C, V1 is equal to Q by C1, V2 is equal to Q by C2, V3 is equal to Q by C3. This one is Q by C1, this drop is Q by C2, and this drop is Q by C3. We can write like this. We will write, since V is equal to potential drop, V is equal to V1 plus V2 plus V3, and V is equal to Q by C. We will write like this. Q by C equivalent is equal to Q by C1, Q by C2, and Q by C3. Q get cut from both sides. We will get 1 by C equivalent is equal to 1 by C1, 1 by C2, and 1 by C3. Like this. And this will be the formula of capacitance for a series combination. Okay. Now we see that if we have two capacitors like this, one is having capacitance C1, another is having capacitance C2, then their equivalent capacitance will be written as product of both of them and multiply of both of them. You should remember this always for your shortcut. Now, if we have, second shortcut is this, if we have capacitance C, we have capacitance C, okay, capacitance C, and all that n times. Then we will write that equivalent capacitance is equal to C by N. These formula are valid for resistance also. Okay. Any problem? Anyone? Any problem? Please reply. Any problem? Anyone? Any problem? Shall we move now further? Okay. Now let us see some question. Practice some question. Okay. Let us practice some question. Suppose we are having this arrangement. This arrangement of capacitance, and if we have applied a potential of 10 volt, this is 2 microfarad, this is 4 microfarad, this is 4 microfarad, and 10 volt. We have to find the charge through this Q. Can you find? I give you 30 second time. Please try. Find Q. Find Q. This one. Please try once. Please try it once. 30 second time. Please try. 30 second time. Take your time and try. Try once, try it once. Okay, any answer? Any answer? Okay, no worry. Now let us see what will happen. Let us see. We know these both two are in parallel combination. We can see their equivalent will be how much? Their equivalent will be 8 microfarad. We know these are in parallel combination, and this 8 microfarad will be in series combination with 2 microfarad. We will get like this 2 microfarad and 8 microfarad like this, 2 here, 8 here, and connected with 10 volt. We know equivalent capacitance of two capacitor in series combination. We know C equivalent is equal to product of both of them and addition of both of them. Okay, we will get 1.6 microfarad. Now we know what will be the charge here. Let us suppose here charge is Q dash. We know Q dash will be CV. CV got 1.5, 1.6 into V is 10. We got 16 microcoulomb charge supplied from here. 16 microcoulomb. 16 microcoulomb charge flowing through here. Series combination, no change in charge. We will get 16 microcoulomb here. Now charge will distribute here and here. Since here both the value of capacitance is same, both the values are same, so what will happen? Equal distribution will occur here. 8 microcoulomb will go here and 8 microcoulomb will go here. Okay, answer will be 8. Okay, we will see if they are different, how we can. So we will take some example also. So our answer will be Q is equal to 8 microcoulomb. If I am not done any calculation mistake, this is your answer. Any problem? Anyone? Any problem? Any problem? Any problem to anyone? Okay, sir, explain nothing. Okay, no worry. What I did here in this question, what I did like this. If suppose what I did here, if suppose I'm having this arrangement of conductor here, or 2 microcoulomb and 2 charges, 4 and 8 capacitance. Let me draw the figure once more and show you. Suppose we are having this 2 microfarad here and 8 microfarad here and 8 or 4, I think it was 4 here and 4 here. Okay, and for the circuit was present here also. Okay, first of all we have to find charge here. So before finding that charge, since it is given that, what we will do, we will find the charge flowing through a circuit here. First of all, Q dash here. After that we will go here. Okay, to find this charge, what we did, we find the equivalent capacitance of the arrangement. Okay, to find the equivalent capacitance, we take the combination of these two capacitance. Since they both are in parallel combination, and we know in parallel combination C is equal to C1 plus C2 like this, C3. So here let us assume C1, C2 and C3. We will say since C2 and C3 are parallel, they are parallel, we will write C equivalent dash is equal to, we will add them, we will write 4 plus 4, that means 8 microfarad. Okay, now it became 8 microfarad. What will the arrangement now? 2 here and we got here 8 microfarad. These two are now in series combination and their capacitance will be equivalent, capacitance will be 2 two capacitors in series. What we do? We multiply them and add them. You know this. I have told you in shortcut also. Using this shortcut, what we will write? We will solve it. We will get 1.6 microfarad capacitance. So we got the equivalent capacitance of this circuit. This is C is equal to 1.6 microfarad. Now we know C is equal to this one. What we will do? We will write Q dash discharge. It will be Q dash is equal to. Now the circuit became like this. The whole capacitance reduced like this. We have single capacitance of 1.6 microfarad, and it is attached with a cell of 10 volt. Now we find discharge Q dash. Discharge Q dash will be CV. C is 1.6 and V is 10. We will multiply, we will get 16 microcoulomb. This is a charge flowing through it. 16 megacoulomb from here. Now 16 megacoulomb will flow here. Okay, if charge is asked through C1, it will be 16 megacoulomb, but it is asking here. What will do? This charge will coming here, it will get separated here and here. How will they get separated? It depends upon the value of capacitance. Since the value of capacitance are same, both side you can see, both both branches capacitance is same. You can see here. So 16 megacoulomb will get distributed 8 here and 8 here. So this side charges flow will be 8 microcoulomb and this charge flow will be 8 microcoulomb. Our answer will be Q is equal to 8 microcoulomb. Now clear our problem? Got it? Still having problem? Please discuss here. Okay. Now, let us see. Let us move further. I'm taking another example now. Let me take one more example. Let us take. I am having this C here. It is 8 microfarad. It is 8 microfarad. Okay. Now 8 microfarad. We are having like this. 8 microfarad. Let me write like this. I write like this. 809. Okay. Here we are having like this. 3. Both are 3 microfarad, 3 microfarad, 3 microfarad. Okay, and the arrangement is like this, and it attached with a cell having potential of 10 volt. We have to find what will be the charge flowing this capacitance. We have to find Q. Will you try? I give you 30-second time to try. Try it once. Try it once. Can you try now? Try it once. 30-second time. Take 30-second time and try it. Try it. Take 30-second time and try it. Take your time and try it. Any answer? Any answer? Any answer? Okay, let us see. Let us see. You see, then you will try. You can try also. See. These 3 charges, look here. These 3 capacitance. Oh, let me try. Let me try. I think you have tried something. Okay, let me try. Now let me try. These 3 are in parallel capacitance, both parallel. So their equivalent capacitance will be 3 plus 3 plus 3. That means 9 microfarad. Now, after solving this, what we are having? We are having 3 capacitance like this. 9, 9, and 9, and both are in series and all three are in series combination. We have studied earlier like this. If we have n capacitance, we have n capacitance. Oh, I think in one of the slide I have written something wrong. I think here. I think here. One of the slide I think, oh, this one. I made a wrong figure here. You can see it is C, C, C. This is not. I have done mistake here. I think C, C. If they are n times, C, 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 C. Then we will write C by n. In this case, for this case, we can write like this: C equivalent is equal to n into C. Okay, and for this, C by n. That only I am using now. That's why I came to know that I have written something somewhere wrong. Now they are in series combination. Okay, you can see C, C, C. Both are in series. We will write C equivalent. Total will be C by n. 1, 2, 3. 3 capacitance. 3. We will get 3 microfarad. Now, total capacitance is 3 microfarad. Volt is 10 volt. We will write Q is equal to CV. CV means 30 microcoulomb. Okay, good. I think you have done right. Okay, 30 microcoulomb, that means 30 from here, 30 from here, 30 from here, and it will get distributed 10, 10, and 10. Good. Your answer was right. Good. Let us see our next question. One more question I give you. Try this. Try this question. If suppose we are having like this, yeah, and we are having like this here. You can see we are having like this. Let us see. It is having 4 microfarad, 4 microfarad, 2 microfarad, and it is having 4 microfarad here. Okay, and it is connected with 10 volt battery. We have to find this Q. Find Q. Can you try? I give you 30 second time. Try this. Try this question. After solving this type of question, the capacitor will be very easy for us. Take your time. Find C equivalent first. Find C equivalent first. And after that, you can find your capacitance. Okay. Try this once. Try this. Any answer came? What you get C equivalent? How much? How much C equivalent? I think problem is coming. Huh? Problem coming now. Now let us see. Let us see. Don't worry. Let us see what is there. What is it? See. These two capacitors here, you can see here, these two capacitors, they are in parallel combination. You can see they are in parallel combination, and we know. Okay. Let me see. These two are in parallel combination. Okay. Let me see. These two are in parallel combination. If they are in parallel combination, we can write here. They are in parallel combination. We know their C equivalent will be 6 microfarad. Okay, now 3 capacitance, 4, 4 and 6. How to solve this in shortcut? How we will do? We know for these two we can write 2 microfarad. Okay, now 2 microfarad here and 6 microfarad here. Both are in series. We can write like this, multiply both of them and add both of them. What will the answer? 12 by 8. That means it will be 6 by 4. Or we can write like this, 3 by 2. I think this way. Am I doing anything wrong? Please check it. Maybe some calculation mistake. Check it. Have done wrong or not? Okay. Okay. Now let us see. If this is C equivalent, what we will do? We have to find this charge. We will find first this charge. Let us say Q dash. Q dash is equal to CV. C we got 3 by 2, that is 1.5 into V is 10, that is 15 coulomb charge. 15 coulomb coming from here, 15 microcoulomb. 15 microcoulomb. 15 microcoulomb charge coming here. 15 microcoulomb charge coming here. Like this. 15 microcoulomb charge like coming like that. Now, they will get separated here. Okay, and we are not knowing. Okay, now let us assume it is having, this is given charge Q, then here it will be how much? 15 minus Q. Okay, if Q charge goes here, the remaining charge will be 15 minus Q. We will find the potential difference across the end. Potential difference for 2 microfarad capacitor will be, we know Q is equal to CV. That means V is equal to Q by C. We will write for 2 microfarad, we will write like this. Q by C is 2 microfarad is equal to, for this one, we can write like this, 15 minus Q by 4. It will be 2 and we will get 2Q is equal to 15 minus Q. And Q will be 5 microcoulomb, I think. 3, I think. It will go over 3 here and after that it will be 5 microcoulomb. You got it? Okay. That means 15 out of 15 microcoulomb charge, how much charge gone there? This side, how much charge gone there through this side? This side, charge gone by 5 microcoulomb here, and rest of the charges, that is 15 minus 5 will be how much? 10 microcoulomb through this branch and 5 microcoulomb through this branch. Okay, any problem till now? One more shortcut I tell you. Okay, now I tell you the one shortcut also. You can see here, there was a 2 capacitor, previous question only. Okay, it was 2 microfarad here and it was 4 microfarad here. You can see here it was 15 microcoulomb charge. First method, one method is universal method by equating the potential. This is very important. Any complexity comes, you can apply this type of formula and you will get the charges through each branch. Now, there is one shortcut also. We know, since we know that, we have learned earlier also that Q is equal to CV. We have learned earlier also that as we know that capacitance C is inversely proportional to voltage, or we can say that C depends on V. We can say that it has more capacitance. You can see this one is having more capacitance. You can see that means more capacitance here, charge will be more. How much more? With respect to this, it is double na? Double. That means if 2 2q charge move this side, then q charge will move this side. Okay, so total charge will be 3q, and 3q is equal to 15. That means q is equal to 5. Here also, by this way also we can solve. Think. Okay, any problem? Any problem you should discuss with me? Any problem? Anyone, any problem? Anyone having any problem? Explain again, sir. Okay. I explain once again. What I did, you please see here what I did. Okay, till now 15 total capacitance was okay. Total capacitance was okay. Total capacitance was okay here. We have found total capacitance here. Now, with the help of total capacitance, we found the total charge flowing through the dash shortcut alone. Okay, nice. Shortcut C. I tell you. Shortcut which I have showing here, it is only applicable. I am applying for here only. Okay, you remember one thing. What is the meaning of capacitance? What is the meaning of capacitance? Let me take one general example. Okay, one general example. Okay, now see. Let me take one general example. You know, since Q is equal to one more thing. If you know, we are having one glass and one bucket. Okay, one bucket, one glass. We know bucket has more capacitance than glass. If capacitance of filling water is more in bucket, that means it can acquire more charges than this. Similarly, when we compare these two capacitors, more capacitance is here, and also by mathematically we can say that Q is equal to CV. That means C is equal to Q by V. Also, since both of them are in parallel combination, V is same. We can say whose capacitance will be more, then it will acquire more charge. Okay, if it is double, then double charge, triple, then triple charge. So for 4 times, then 4 times charge, like this. The relation is valid here. Now we will see that here we see that 4 microcoulomb charge is double of 2 microcoulomb charge. That means more capacitance, it is double of this. This means if it can hold Q charge, then it will hold 2Q charge, because more capacitance and is double of it. Okay, now Q here, 2Q here, total charge at this point will be 3Q, and this 3Q is equal to 15 microcoulomb. We have calculated earlier. By this we get Q is equal to 5. Okay, now similarly, if suppose like this, any question you got like this, 2 microcoulomb here, and you are having 6 microcoulomb here, like this. Okay, what you will do? You will take Q charge here and write 3Q here and solve it. 4Q, compare charge 4Q here. With the charge given, you can find the respective charge. Okay, got the shortcut now? Let us see. Let us see further. One more question I give you. One more question. One more question like this. Suppose I am having this capacitors like this. Like this. And I am having, naming it like this, 2 microcoulomb, 4 microcoulomb, 6 microcoulomb and it is 6 microcoulomb here. What I did, I have taken one circuit like this, connected here, and one switch here. Okay, we have to find the like this. We can see like this. Find the we have to find like this. Okay. Find the ratio of charge flowing. Find the ratio of charge flowing through ratio of charge supplied by cell or battery when first switch is open, and second when switch is closed. Two cases given when switch is closed. Okay, when switch is open, then how much charge will flow here in this tube, and when switch will close, how much charge will flow. We have to find these two things. Okay, now first we assume switch is open. If switch is open, we have to take total capacitance here and just solve it. We will get Q directly. Okay, let us assume this will be Q1. Now if second case switch is closed, what will happen after closing the switch? When switch will close, these two capacitors will become useless because charge will flow through the less resistance path and no charge will be flowing through these two capacitors, and these two capacitors will be useless. Okay, and it will be like this. Okay, now, and then find this Q2 and take ratio of Q1 by Q2. Okay, this will be the answer. You can solve it similarly. Okay, now let us take one more question. Good question. One more question. It is given C here like this and like this. Here it is A, it is B. Okay, we have to find equivalent capacitance across AB. Can you find? I give you 10-second time. 10-second time. You can try it. Try it once. Try it once. Can you try it once? Few more question. I will give you the homework also. One more question. Try it once. Try it once. And also take one more question as a homework. This will be a homework also. Let me give you one more question. Let me give you one more question like this. Okay, 3C. You know how to solve this question? I don't know the answer, but I have to see. This will have, suppose, potential V. Let us say 1 point. First 1 point. This will also have potential V. That is same point 1. Okay. This will have potential, suppose V1. It is 2 point. It will be a 2 point. So we have 2 point, 1 point. At 1 point we have this capacitor and these 2 capacitor. Okay, I think these 3 became like this. Okay, okay, okay. I got it. Now, let us suppose we have one big plate having area A, and area A, width of this plate, and we are having consecutive 3 plates like this. It is having, let us suppose it is having d by 3 and d by 3 width like this. Okay, it is here, distance is given like this. It is A, it is also A. Okay, you have to find capacitance, between plates. Okay, take a screenshot, try this question. This is a very good question, though I know it is a JE question, but you should try. Take this as one capacitor, this as another capacitor, and this one as another capacitor, 3 capacitor, and all the 3 capacitors, they are connected through series combination. You can use this series or parallel, you have to decide. I will not say, you have to decide. Okay, maybe parallel also. Okay, and one more question. Okay, last page. Okay, one last question I give you. Last question. Today we have reached to a last page of a Rizee. Very good. Let me take one more example. Last homework. Wait, we are having, I am giving you last homework like this. Capacitance having dielectric field here, C, and K1 here, and K2 field here. Originally C is equal to epsilon naught A by D given, but what we did, we modified like this. We have to find capacitance of modified capacitor. Okay, what will be after filling this capacitor like this here and like this here? These are 2 plates, one plate here and one plate here. Okay, can you try? Will you try now? Tomorrow we will discuss. If you get problem, then we will discuss. Okay.